introduction. Hey students, it's me, Mr. Fitz. So I'm going to make a quick video, hopefully it'll be quick, on triangle congruence proofs. And specifically Cpctc. And what is that? Well, if we can prove triangles congruent, then we can prove all the other parts of the triangles are congruent, and then we can prove other things. So let's take a look at an example. So what is Cpctc? Well, let's look at the matrix. What does this mean? Well, it's corresponding parts of congruent triangles are congruent. That's what that means. And you're going to see what I mean by this in a minute. So let's think about this. If we had to prove triangle ABC is the coldest triangle out there, which is isosceles, then let's think about how we can do that. Well, all right, I have some ideas. So let's go through it. So the first thing when we're going to do a proof is we're going to mark the diagram with the things that we know or we can prove. So they've given us one set of sides and then one set of angles here. That's given information. But I also know that this angle here, BDA and CDA, those will be congruent too, because they're going to be congruent supplementary angles of congruent angles. And then also I know that this is going to be congruent to itself, this line segment AD. That's known as reflexive property. So if that's the case, here's my plan. And see if you can follow me here. And this is step 2. So step 1, you mark the diagram. Step 2, you make out our plan. I'm going to prove ABD is congruent to ACD. So these two triangles on the left here, these kind of like obtuse triangles here, using side angle side. And it looks like I can do that, right? So if I can, and how I'm going to do that is, and so BD is congruent to CD. That's given. That's these line segments here. They mark the diagram for us, so that's given information. ADB is congruent to ADC. That's these angles I marked in red right here. And why? They're supplements of congruent angles, so they're congruent. Supplementary by the way means add up to 180 degrees. So line segment AD is congruent to line segment AD, and that's a shared side. It's in both triangles. You could even just say shared side or reflexive property. So those are the 3 things I'm going to use to prove these triangles congruent. Two sets of sides and the included angle. So it's a side angle side situation, kind of like a angle sandwich or something. Okay. Then, well, AC is congruent to AB. So these line segments here, because the triangles are congruent. So since the triangles are congruent, I know those sides have to be congruent because they're corresponding parts. What does corresponding mean? They're in the same place and relative place in a different triangle, right? And then triangle ABC is isosceles because the legs are congruent. So that's my plan. Let's go ahead and write out the proof. So you're going to start with 2 columns, statements and reasons. Always start with your given information every single time. So you're just going to write out your given information. BD is congruent to CD and angle EDB. That's the angle symbol, EDB. Remember the angle, the vertex goes in the middle. And angle EDC, they're congruent. But these green ones, EDB, EDC, and that's given. Okay. Number 2, AD is congruent to AD by reflexive property. Let me put the little line segment on there, a little bar on that. Yep. So don't forget to put a little bar on top of otherwise you're just listing 2 points. So line segment AD is congruent to line segment AD by reflexive property. 3, angle BDE and angle BDA and angle CDE and CDA are supplements, meaning they're these 2 sets. So this angle here and this one here, they're supplementary. And CDE and CDA, so these 2 bottom angles are supplementary and the 2 top angles are supplementary. Why? They form a linear pair, or you could say they form a straight angle or something like that. Anything along those lines. They form a straight line. They add up to 180 degrees. So if that's true, then I can say BDA is congruent to CDA because supplements of equals are equal. Now you couldn't list this number 4 ahead of number 3. You needed this number 3 to prove this one. You could have put this number 2 like down here because that's not dependent on anything else. But these two are dependent on one another. This one's dependent on this one. So that's why like order matters in a proof. So it's like you're building your case, right? So therefore, triangle BDA is congruent to CDA. So this triangle on the top is congruent to this triangle on the bottom here. Why? Side, angle, side. Okay. So AB is congruent to AC. So this side length here, let's go ahead and highlight that. This one and this one. So those two side lengths are going to be congruent to each other because corresponding parts of congruent triangles are congruent. You can just write that out however you want. If you want to abbreviate, you could say Cpctc, but the problem is if you mess up your abbreviation, somebody might not give you credit. So I would just write it out, just say, hey, because the triangles are congruent, so are all the other parts. Something like that. Okay. Therefore, triangle ABC is isosceles, super cold, because the legs are congruent. So this whole triangle, this thing, is an isosceles triangle because these legs, which we just now proved, are congruent to each other. Okay? So hopefully that helps. Please let me know if you have any questions. And thanks so much for watching.